The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. I see that I've got 11:01. A lot of people are still logging in. I'm going to go ahead and wait for about another 30 seconds, and then we'll get going here. So thank you for everyone in attendance so far. All right, I've got a time of 11:02. We will get started. So good morning, everyone, and welcome to another great edition of the Skillshare webinar series by the National Center of Pavement Preservation, hosted by the Midwest Pavement Preservation Partnership. My name is Rob Green. I am with the Michigan Department of Transportation, and I'll be your host this morning. Our moderator is my good friend, Phil Rufus from Missouri DOT. Before we get started, I wanted to share a couple of comments. For those of you who are new to our webinar series, ours are a little different than some of the standard webinars out there. The meat and potatoes of these webinars really comes down to the panel discussion. So we'll hear 4 great short presentations. The point of these presentations are just kind of to get whet everybody's appetite. But then really it comes down to the panel discussion, and that panel discussion is going to be driven by you, the attendees, with your questions. Please take note of the question pod within the menu there. As you come up with questions, as you're hearing different things that the presenters are sharing, please put your questions in at any time. When we get to the panel discussion, we will then go ahead and start answering those questions accordingly. Wanted to share with you that we are working on our next Skillshare webinar already. We are planning either May or June, so please stay tuned for that one. Last comment is that there will be an email at the end of this broadcast that will contain the PDH certificate coming from Michigan State and the National Center. So with that being said, let's kind of get things kicked off. There is no doubt the safety benefits that come from placing centerline corrugations in our pavements. However, agencies and pavement managers have been debating the impact they play on the service life of our pavements. Today's webinar, we're going to explore a broad perspective as it pertains to corrugations. We're going to hear what the research is saying regarding the continued effectiveness as different treatments get applied over top of the corrugations. And we're going to hear about the durability of the corrugations as it pertains to the service life of the pavement. Lastly, we'll hear some agency perspectives on how they are maintaining their corrugations. Today's panel consists of Bryan Wilson from Texas A&M Transportation Institute, Daniel Swiertz from Asphalt Materials, Travis Hansen from the Utah Department of Transportation, and Nancy Graham from the Minnesota Department of Transportation. We recognize that our audience stretches from coast to coast, and so does our panel. Without any further delay, I'm going to turn it over to our moderator, Phil, and the rest of the panel. Thank you.
Thanks, Rob. As we start today, the first person I'd like to bring up, coming to us from now cloudy but soon to be sunny Houston, is Travis from the Texas A&M Institute for Transportation. Travis, as we get him ready to go ahead, everybody, and go and do our quick poll that you see, just to give us an idea on who we have today as we begin and our transfer into the meat of the presentation. I'll give you a couple of seconds while we have the poll up, and then quickly introduce Bryan and let him go. Okay, that's about enough time. Bryan, let's cue you up. Okay, Bryan, you're ready to go. Bryan Wilson, everyone. Bryan, you may be muted, sir.
Hi, my name is Bryan Wilson. I'm with the Texas A&M Transportation Institute, and I have 2 research projects that we recently completed. The first that I'll talk about is from the Texas Department of Transportation, looking at the effect of putting seal coats, as we call it in Texas, other people call them chip seals, putting multiple chip seals down over your rumble strips and how that affects the sound performance. I'm also wrapping up just now a project with NCHRP looking at guidelines for the maintenance and construction of rumble strips. In this case, we're looking at how different construction methods and maintenance affects the actual pavement condition where those rumble strips are, and how those rumble strips could be improved to improve durability. Because that project is still wrapping up, I'll only touch just briefly on it at the end here. So most of this will be about the TxDOT project. So we defined sound performance of the rumble strip in terms of the change in noise when you're driving in the wheel path and then crossing over the rumble strip. In this case, the wheel path, the noise or the sound there was about 64 decibels. When we went on the center line, that jumped up to 80. So the difference is a change of 16 decibels. When looking at some of the literature for this project, we considered a high-performing rumble strip as being greater than 10 decibel change, moderate being between 6 to 10, and low performance being below 6 decibel change. So the goal of the study was to really determine how many layers of a chip seal can you put down before you consider the rumble strip performance compromised. So we had 34 chip seal projects around the state, a total of 54 rumble strips that we measured, and we looked at the sound and vibration before and after putting down the chip seal. We equipped inside the vehicle, we had a microphone next to the headrest, and then we put accelerometers under the seat and on the steering wheel. We tested with a pickup truck and a passenger car going at different speeds. I'll just hit on just the summary results here and focusing on the sound. So just some pictures here so you have an idea of what's going on. This is an asphalt concrete pavement beforehand, and it had a noise performance of 17 decibel change. After we put down what we call a grade 3 chip seal, that dropped down to 7 decibels. The grade refers to the size of the rock used, with grade 3 being 5/8 inch chip. Here's another example. So this had already been covered once, and it had a performance of 6 decibels. You covered it again, and now it drops down to only 4 decibel performance, and basically you can't even see it. So just a high-level view, we found that looking at when there were no rumbles, when it wasn't covered at all, on average we were about 14 decibels performance. That dropped to about 8 decibels after one seal coat or one chip seal, and after 2 and 3, they were basically the same at about 5 decibels. Now, this is the trend overall, but I put this bar here, this long bar that has a very wide range. This is actually the range of data that we saw within all the projects that we tested. So in some cases, you had a rumble strip that was newly installed, but was almost on the verge of not performing well enough. Whereas some of these, even after 2 rumble strips, two chip seals, some of these rumble strips were still performing pretty well. So what we found was really it's not just the number of chip seals that goes down, but it has to do with also the depth of the rumble strip initially. It has to do with the size of the rock that you put down. And really the best predictor of whether your rumble strip will be okay is if you can measure the noise beforehand. Now, we understand that's not practical in all cases, but this just shows, this is the model when you include the sound beforehand, if you can measure that, then you can actually get a pretty good prediction of your sound afterwards, R squared of 0.7. But we looked at some other models, assuming you can't get the sound beforehand. So we have 3 models. The first, again, you go measure the sound and you also measure the rumble strip depth. You have a pretty good prediction. If you don't have the sound and all you know is just the rumble strip depth, you have a moderate accuracy prediction, about 0.5. And if you don't know anything about your rumble strip, you just know that it's there and that you're going to put a chip seal on top of it, you really don't have a lot of accuracy to know, what the result will be. R squared is 0.3. But we did make these models, and so somebody could, depending on what information they have, they could run this little equation here, or they could look at these graphs and predict, if I'm going in with 10 decibels, what do I think I'll get afterwards if I put down a grade 4 chip seal, for example. But the high-level takeaways, these are just rules of thumbs that we can extract from these models. The first is, it's okay to use a chip seal over an uncovered rumble strip if you're using what we call a grade 4 or a grade 5. So that's a half-inch chip or less. So if that's what you're putting down, you can put down 1 chip seal and you should be fine. If you're putting down a larger chip size, then you got to do a little more digging to see if your rumble strip is compromised. Also, if you have really good sound performance beforehand, greater than 15 decibels, and you have like a rumble strip, a typical rumble strip that's a half-inch deep, you should be fine. You can seal it. We found that if you want to put down a second chip seal and you don't know anything else about it, like the depth of the rumble strip, there's a good chance that you're not going to get the performance you want. You really need a bit of information like the depth or the sound before you put on that second chip seal. We also found that if you're a district in Texas that uses that larger chip seal size, consider installing your rumble strip deeper to avoid needing to reinstall the rumble strip later, or apply a smaller chip seal, a smaller rock size. I just wanted to touch real briefly on the NCHRP project we're doing that actually finishes this month, so the publication should be coming out soon. This included a survey of 30 states. We did interviews with the industry. Then we went and measured the distress of 110 rumble strips spread across 12 states, looking at pavement type, location of the rumble strips, on the joint, off the joint, what kind of maintenance was done. We looked at rectangular rumble strips and the mumble strip, or a sinusoidal strip, and then we even produced some guidelines for that. And I can't really go into the details here, but just high level, here's the kinds of problems that we saw on the road. We gave them a rating of 10 being a perfect rumble strip and a 1 being completely failed. We even looked at different ways of milling that in. And I won't go through and read all this, but we did find some things about, which pavement types were better. Chip seals tended to have a big issue if you mill into a chip seal. The pavement age really affects how well your rumble strip's going to last. When if you mill into an old pavement, that's going to affect it. Longitudinal joint construction is important, as we'll hear later on. And then we found too, you can install with different types of milling heads, and you can change the quality of the cut, but that doesn't really affect your overall rumble strip life. So like I said, that whole study is ending this month, and we'll have the results for that soon. So thank you everyone for your time, and I look forward to the panel discussion.
Thank you, Bryan. As we transition to our next speaker, we're going to go ahead and throw another quick poll up in front of you. As you can see it on your left, give a couple of minutes. Again, the reason I'm asking these questions are I can understand kind of where our team is coming from, and as I kind of direct the questions as I've sent a chat to everyone to the right person. So a couple, maybe another 6 to 8 seconds, we're going to queue up our next speaker. And we're about done. Our next speaker, as I slowly transition out of this, is Dan. Dan comes to us, actually, he's done quite a few presentations for us in NRRA, which is the National Road, I just call it NRRA, where MoDOT has been participating in several studies with them. So Dan comes to us, let's go a little bit, well, let's go actually substantially north, and join my friend up north to discuss our next step as we kind of delve deeper and deeper into the practical applications, still high level right now, of these particular mumble and rumble treatments. Dan?
Sure.
We're not quite there yet.
Yeah, I'm not seeing the share panel unless if Rob hasn't shared it with me.
I see you right now.
You can see me. I can't. What I'm saying is I don't have the take control panel up available.
That's okay. Todd, help me out. Oh, shoot. I tell you, we practiced this, everyone, and it went smooth as silk. But unlike when you take your car to the mechanic, it doesn't seem to want to make that noise, does it? Okay, Dan, you're ready. Now you're muted.
Ready to go, finally. That's why we practice, right?
I'm excited to once again introduce Dan. Please, Dan, share us.
Sounds good. Thanks, Phil. Apologize for the technical difficulty here. Yeah, again, my name is Dan Swiertz. I'm an engineer with Asphalt Materials, operating out of the upper Midwest. And as Rob kind of touched off with at the beginning of all this, like most areas of the country, we're seeing greater and greater use of centerline rumble strips on new construction projects. And the data is clear on the safety benefits, but I think, you know, as pavement engineers concerned with longevity and durability, there've always been questions about the effects of milling. So this title is certainly tongue-in-cheek, but it kind of sets the stage for what we're aiming to look at here is the counterbalance of functionality on one hand, that would be like the safety, and durability. You know, are we kind of hamstringing our efforts to make our pavements last longer by milling these things in? The literature on this topic is fairly incomplete, and by no means is this one slide review exhaustive, but I think it tells the right story here. Many of the assessments that you'll find in the literature, and at least among us as practitioners, are anecdotal, observational at best. There are comparatively few studies, but there are some that carefully looked at this phenomenon in the lab. And generally what findings show is that introduction of rumble strips via milling may cause some damage. How that damage manifests in actual field performance is lacking. Rumble strips could, as you might expect, as just kind of understanding what we're doing by milling a corrugation into the pavement, change the water dynamics at that location. Something like permeability could be used to measure that. So these are things that have been thought about, have been measured in the lab, although at a limited scale. And I mentioned that term counterbalance, and of course, we need these things to function as safety tools. That's what Bryan was mentioning. And what we found, and we'll jump into how we were looking at this, is there's very little standardization among agencies. So as we jump state to state, most of them have unique rumble strip geometries that they use. Findings published this summer, actually, as part of NCHRP, found that geometry strongly affects functionality. And Bryan touched on this too. In other words, if you change the geometry, treatments notwithstanding, you will change the functionality of the strip, the driver alerting capabilities. And then there's one other component, which is where mumble strips come in, is sort of the noise pollution aspect, right? Like how much fugitive noise that's not really helping with safety, but could be annoying your residents and generating phone calls to the agency and complaints and so forth. So we wanted to look at that as well. To that end, it brings us nicely to this ongoing NRRA study, and the title of the study is there, and we'll put a link later on. But really what this is, it's an effort to gain field data, field projects as controlled of a study as possible, and asking these three questions. Does milling of rumble strips damage our pavements or produce the conditions that are conducive to damage, facilitate damage, you might say? And can that be offset with material treatments? And Bryan's the perfect setup man here, because we also wanted to say, well, we can't be blind to the fact that these material treatments, if they affect the functionality, may not be the right choice. So we wanted to make sure that they did not impact functionality as a safety tool. To accomplish these objectives, we built 3 projects in the state of Wisconsin. So for those unfamiliar, this is like the southern half of Wisconsin, and my what would be red stars here are showing where these projects are built. So these are rural, 2-lane undivided, 55-mile-an-hour marked roads, all in the county highway network. And we built projects that had up to two material treatments, one underneath, that would be a void reducing membrane, one on top, that would be like an asphalt emulsion fog seal, and then the combination of those two, and then control sections. So in all, we would have 8 sections per project. 2 of these are in carbonate stone areas, so like limestone based mixed designs. One of them is in a silica based, it's a granite mixed design. 2 of them got standard Wisconsin DOT corrugations, which for us, that means paired rectangular, like half barrel, half circle corrugations that are paired down the center line. And then the 3rd project got sinusoidal or mumble strips to the WISDOT spec. And for us, that's a 1/2 inch max mill depth and just scouring the surface at the high points. And then a 14-inch wavelength for our sinusoids. But that's all information that's easily able to look up. I like pictures. I'm a construction guy, so how these projects were built, you're looking at a base layer, as we would call it in Wisconsin, or a lower layer being marked out for the sections. We tried to get sections that were at least a 1/2 mile long to be representative of paving variability, base changes, things like that. Mark them out within the project. For those of you familiar with void reducing membrane, that goes down on the base layer before you pave the surface layer. Here's a picture of application of VRAM in one of those sections. Another picture, VRAM is centered at the joint. So you could think of it as like putting a piece of double-sided tape down. You're going to pave on half of it first, and then your second pass is going to hit the other half. So here's paving the upper layer on the VRAM section. We asked the counties, in this instance, these are county highway agencies, follow your standard construction practice. Act as if we're not there and we're just going to put these treatments on, mill the rumble strips, and measure. So in this instance, quality control testing via nuke density of the joint layer to collect that information. We want to make sure these treatments don't affect the ability to build a good joint, and we'll get to that as well. Milling of the rumble strips, this is something that most of us are familiar with. So this is WISDOT standard corrugations. So these would be paired. In other words, I consider this one pair, 18 inches offset from these would be another pair, and so on and so forth. So you kind of hit these things and it's like, zzz, 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 as you go down the road. So this is standard geometry. Of course, we had one project that did the mumble strips, as they're called, or sinusoidal, which is a fun word to say, and I prefer that. So this is sinusoidal geometry, what it looks like immediately after sweeping and ready for striping. So the first material treatment, VRAM, that goes underneath the joint. We would call that a pre-construction treatment. And then we did a post-construction treatment. In this instance, we did a penetrating asphalt emulsion fog seal. Nancy will touch on another type of surface treatment, but suffice to say these are focused on the centerline joint to provide some sort of residue, be it in this instance asphalt, it could be like a rejuvenating oil, any number of things to the surface at this weak point of our pavement construction. We wanted this to be true to form. This is a field study, takes into account all the different things that can happen with field construction. So we went out and we cored these. We gathered enough cores that we could fulfill our suite of testing, which we'll show you. And then, of course, we wanted the sections to be long enough, not just for variability, but we wanted to measure noise. And Bryan touched on this. We did internal noise and external fugitive noise and vibration. This is just how we set up for our noise testing following NCHRP guidance from the study that came out. I believe it's the report is 1102 this last summer. This is how internal noise is measured. This is how external noise is measured. And then the gentleman we'd clear the road, close it off, drive down that center line, and you can see the technician on the sideline here taking that measurement. You make 3 passes, it's averaged, sent through sort of a filtering algorithm, and that's your result. Take the cores back to the lab. We wanted to focus on make some baseline assumptions. You know, the centerline joint's not expected to carry significant load other than incidental crossover traffic. So sort of thermal movements and any sort of fatigue type movements are key. Of course, water infiltration at the joint has long been known to deteriorate longitudinal joints quickly. So measured things like permeability, and then our standard volumetrics. So every core that we got was put through some subset of this testing, really as an investigative mission. What is happening when we mill these rumble strips? Can it be measured? And if we jump right into it, what we're learning is actually challenging some of our beliefs. And what we observed, to get right to it, is the milling of the rumble strips did slightly increase air voids on average, consistent over the projects. But we did not observe a statistically significant change in aggregate gradation on the cores, which meant that there was no, I don't want to say no, there was less impact of degradation from the milling. So although we can see the aggregates get a little chewed up, it didn't affect it on a bulk sense. And evidently, the voids that were created were not interconnected, because what we found is that the rumble strips did not significantly increase permeability after they were installed. So something we'll speak to later is these projects were constructed in the joint cores with no treatment, no rumble strips, would have been considered impermeable anyway, and the rumble strips didn't change that. So kind of good in, good out, right? We don't have a case where it was a poorly constructed joint and you milled rumble strips. Perhaps Bryan's NCHRP study will shed some light on that. I did forget to add, and I'll add it here. In Wisconsin, we use mostly dense graded mixtures for this type of application, and we are a fine graded state. So we because of our aggregate resources, we tend to design our mixes fairly fine. So when you see the air void range here, this is of the core on the center line, and this is generally, I put a line at 10%. That's WISDOT's maximum allowable voids for their longitudinal joint density spec. I only put it there to give you a reference. It means nothing other than for the local spec, but you can reference it to your own spec as well. And of course, changes in asphalt content more readily apparent for the VRAM material because of the amount that you're putting down. VRAM is put down at a comparatively high rate relative to the fog, especially, and that's easily detectable in these lab tests, and it'll come to play later as well. When we looked at cracking behavior, and there's much more to it than this. I chose one slide from one project on one test. One really notable trend was seemed to manifest over and over again, and that was using the overlay tester. The overlay tester is kind of like a fatigue type test where we fix a maximum displacement at the joint on one side of the joint relative to the other, and we just move it back and forth. And what happens, I put a red arrow here, a little fatigue type crack kind of manifests and grows through the sample. And you can see this is a failed sample, the crack going all the way through it at the location of the joint in the field. So we think that this is a good, as good as we can do representation of how a joint kind of opens up in the field with this overlay tester. One of the parameters you measure is the so-called crack propagation rate. That's like, relatively speaking, how quickly that crack grows through this sample, whether it starts at the top, bottom is irrelevant, just how quickly it grows. So it's like damage progression, if you want to think about it that way. And what we found is milling of the rumble strips, actually from a statistical point of view, significantly increased this rate. This is a non-load related type test. It's a fatigue type test. So what that means is, we looked at that literature and we said, well, if researchers are telling us that the milling might introduce stress concentrations or these micro cracks, micro damage as we might call it, that actually does have an effect on load cycles, in this case for fatigue, right? It promotes that crack growth at a higher rate. So it sort of validates what other researchers have found in a direct way with these lab samples. And this was repeated over the three projects, both aggregate types and both types of rumble strip geometries. So it's a consistent trend that we're seeing, at least for these projects. So our second charge was, can we treat the cause and not the symptom? In other words, we could crack fill, but what's causing the crack, and can we treat that? And if it is this micro cracking, it would stand to reason that some sort of a treatment that's almost like a stress absorbing layer or promotes high asphalt content, transfer the mechanical response at the joint from aggregate contact or composite to purely viscoelastic. So pump it full of asphalt. You're not riding on it. You're not worried about rutting or anything like that. And we should be able to delay crack growth, or the rate of crack growth. And indeed, that's true. For all three projects, what we found is that VRAM was highly effective at doing that. So you can see kind of the order of magnitude in terms of this crack progression rate change. But it also statistically evened out the non-rumble strip versus rumble strip sections. In other words, it mitigated the effect of grinding them, milling them in, but it also statistically lowered the crack progression rate relative to control sections, rumble strips notwithstanding. The fog type treatment, we didn't see as consistent of an effect. There was an effect, not always as readily apparent, and this example is a good case study in that, but the other two projects we have data as well. That could be a few reasons. It could be where the crack is propagating from. It could be the amount of asphalt you're adding. And I'll be careful to add, that doesn't mean that the fog type treatment can't be effective at helping prolong the life of a rumble strip. It might just have a different mechanism, right? Maybe it's a water sealing effect or so forth, if we believe like stripping or moisture induced damage is a large contributor. We did mention we wanted to look at functionality as well, make sure that these treatments could maintain the safety benefits of this rumble strip. And Bryan hit on this. Generally speaking, in the industry of functionality testing of rumble strips, we're looking for an on-off interval, meaning the ratio, the difference between when you're on the strip and off the strip of at least 10 decibels to be considered a high functioning rumble strip. So that's why my green line is at 10. Higher is better. It just means the driver got more of a jolt in terms of vibration or noise. If it were in this instance in decibels, what you can hear. And what we learned is that these treatments actually do not impede the rumble strip's ability to be a rumble strip, right? We maintain that driver safety over the three projects, over any of the treatment combinations. So this is two different types of rumble strips, three different mix designs, and three treatment scenarios: VRAM, fog, or fog plus VRAM in this instance. So that's a good thing. Importantly, these are brand new pavements. So dense fine graded mixtures tend to have relatively low off rumble strip noise. Something Bryan touched on is chip seals increase the ambient noise anyway, right? So rumble strips aside, just driving on a chip seal is louder. So your on-off interval is actually affected by that as well. Age of the pavement also matters. So we know pavements typically increase about 1 decibel per year of aging, right? So that's not to say rumble strips might change, but if the baseline is changing and getting higher, you would expect the ratio to actually go down. So I want to be careful to say this is on new pavement. Older pavement might show something different, but we don't think that the effect of the treatment would be that detrimental even then. kind of curiously enough, from the noise pollution side of it, one of the reasons mumble strips have gained such popularity is reduction in fugitive noise. And the mumble strip project for us is this Wood County project. And does that hold up? Well, on baseline, if we look, it turns out that indeed that is true. The Wood County, and I know this is small data set, it actually has the lowest ambient noise and has good driver safety. So that holds up here, right? This is a lower noise emitting strip, but the driver is still alerted. But interestingly, we found that these treatments actually lowered fugitive noise, ambient noise, especially the VRAM, relative to control, relative to just the rumble strip untreated. And we struggle to understand a little bit why that could be. It could be asphalt content, interconnected void structure, any number of things. But asphalt is a noise kind of absorber, a dampening material. So kind of a happy accident, if you want, right? This stuff doesn't affect safety, and it actually would help with fugitive noise. By the way, for this particular noise study, a change of 2 decibels is considered to be within about the cloud of data, within the variability of our ability to measure it. So in this instance, let's say from just over 16 decibels down to about 12, that would be considered statistically significant. You would be able to perceive that. So we had to present a summary, again, ongoing, but to remain faithful to our charge here. I'll say this: rumble strips don't appear to be the boogeyman that perhaps they're sometimes made out to be. They're not the death sentence to the longitudinal joint. But when we found, let's not talk about treatments, let's just talk about construction. Constructing a high quality joint is absolutely paramount, right? Good in is good out. So you build a good joint, rumble strips probably aren't going to be a huge problem for you. That's not to say, though, that these treatments can't help you. They can't increase reliability, because they can, because rumble strips do impact these durability parameters, at least to some extent, depending on mix design and project scenario. So we found material treatments, they can offset any sort of damage that's caused. They can improve the durability at the joint, increase reliability, but it depends on the mode of failure you're looking for. So we found the treatment that had the highest impact, so the most asphalt, highly polymerized, kind of transition that mechanistic response, had the greatest effect. Probably not that surprising. Unfortunately, in the context of durability for pavements anyway, we need time and age. These cores were taken the year of construction. Now, the pavements still sit out there. They've been down there for several years now, and we can revisit. And that's kind of the next steps here is things like moisture-induced damage, freeze-thaw effects. We need time. We can't simulate that great in the lab, so we're going to have to revisit. So these are very preliminary but positive results. I'll put this up here, and I'm sure there's plenty of time for questions, but my contact information, and then I'd be remiss if I didn't offer a chance for you to go see the project webpage. All the project report data and so forth are posted up there. But appreciate your time. Appreciate the moderators for allowing me to present here, and we'll be attached at the end if there are questions. So thank you very much.
Thanks, Dan. Wonderful. I actually learn something every time I see it. So I appreciate your time. Let's go a little bit deeper. Let's come down into some practicals. Let's go, I don't know. You know what? Let's bring some of our new friends out west to us. Go ahead and answer my poll as I set up one of my friends from Utah to take us even yet a further step down toward practical applications. I'll use this time to ad lib to tell you, I hope I've answered the question about the percentages in the polls. In fact, thank you. There it is right there. That comes up and gives you some of the answers. With the reference, I think to answer your question, Greg, we have over 100 DOT people on this call. So how exciting is that? So let's bring our polls down, and let's bring my friend Travis, who comes to us all the way out from Utah in our Rocky Mountain partnership, I being part of the Midwest. As Travis cues up his presentation, Travis is going to take us and bring us more of a DOT type view as I wait for Travis. Oh, good. Yes. So, how's the weather out there?
Well, the weather's
Travis,
fine.
Still, as we.
I don't have the option to share showing up.
Master computer person, would you go ahead and give my good friend Travis?
There we go.
You're ready. Go ahead, Travis.
All right. I'm Travis Hansen. I'm the pavement management engineer in Region 4 for the Utah Department of Transportation. I've been in this position for not quite a year yet, so I definitely don't consider myself an expert in the subject matter, but I can speak to what we are doing in Utah and how we handle the preservation of the rumble strips on our preservation treatments. So like I mentioned, I'm Region 4's pavement management engineer, and that's roughly the south half of the state. It's we have a lot of rural routes with lower traffic volumes. So rumble strips are an important safety feature on these routes. And a lot of them, because of the narrowness of the roads, all we have are the centerline rumble strips and nothing on the shoulders. But for our typical preservation projects, they fall under either chip seals or microsurfaces. And with our chip seals, the rumble strips are usually in the asphalt before we come in with their preservation. So, and if it's new construction, the chip seal, the rumble strips will be installed, and then the chip seal becomes the seal coat for the rumble strips. And here in Region 4, and I think we do vary a little bit between different regions here in Utah, just because of the difference. I mean, it's a huge geographical difference, and we have a lot different traffic patterns in my half of the state than the other regions. But we've allowed the rumble strips to be sealed twice before they're reground. And then the other preservation type project that we do a lot of is microsurfaces. And this is typically where we have higher traffic volumes, or the work needs to be completed at night. And with these, we've filled the rumble strips with microsurface, and then applied another microsurface coat across the entire roadway. And then the rumble strips are reground, and just the rumble strips are sealed with a flush coat, and typically that's an asphalt polymer treatment that we'll use. I'm kind of glad I have this opportunity today. I wasn't so sure of it when they asked me to do it, but it's given me a chance to do a little bit of a deep dive and see exactly what our specifications and standards say about rumble strips and how we should be treating them. So I started by looking at our standard drawings, and they kind of spell out the dimensions and spacing of the rumble strips that we have, you know, depending on which routes they're on, whether it's a bicycle route or a divided highway or freeways. And the only thing our standards really say that's relevant to preservation is that all rumble strips on bituminous pavement surfaces need a flush coat. And then it points you to the standard specification, or the specifications. So I looked at our specifications and what we spell out, and it's kind of along the same lines. I've highlighted just the preservation related things. Install longitudinal rumble strips after the final wearing course, except when a project includes a chip seal coat as the final wearing course, and the chip seal coat becomes the the rumble strip seal at that point. And then apply asphalt flush coat or seal coat on microsurface HMA or SMA surfaces after the longitudinal rumble strips have been installed in the roadway. So for chip seals, this is what we do probably the majority of in our region here. I've included a couple photos. This is on the same route. There was an SMA surface put down in 2014, and last year half of it was chipped and the rest of it will be chipped this year. And you can kind of see there's a pretty noticeable difference. Hopefully you can see that. The photographs are kind of hard to see when you're taking pictures of black asphalt, but like I mentioned, we'll usually seal it twice before we consider the need for regrinding, but obviously we need to evaluate that project by project and just make sure that we're confident that they'll function as intended and be acceptable. So the other one that we do a lot of is microsurfacing, and our microsurface specification, like I mentioned, it says to fill the rumble strip prior to applying it across the entire roadway, and then those rumble strips will be reground. And then they are, after they're reground, they're sealed with a flush coat. In 2023, and this is before I was in this position, so some of this information is kind of secondhand, but we tried to do a test project with microsurface and see if we could handle it like we do a chip seal and cover them once and then just not have to regrind them. And we did a section on I-15 that was about 6 miles or so, and we did a test section on I-70, and these are both undivided, or both divided freeways. The one we did on I-15, I guess they weren't real happy with either one of them after they did it. The one on I-15, they came back and the following year they had them reground with an adjacent project. And the one on I-70, they decided that they would leave in place. And the maintenance foreman down there says they've improved with time, but I don't know if that's truly the case or not, because we don't have a real scientific way of measuring if they actually have improved or not. But some of the factors that we talked about, why they may have worked better on one than the other, is like has been mentioned by the other presenters, just how deep they were before the preservation treatment, how well they were cleaned prior to the microsurface, and then, you know, what was good and what wasn't was kind of subjective based on how they felt or how they sounded. But kind of as Region 4, that's how we've handled it, and we've decided to continue to fill the rumble strips and then regrind them on a microsurface project in the future. That's really all I have prepared, and I'll turn the time back over to Phil, and if you have any questions, go ahead and put them in the chat box.
Thank you, Travis. I appreciate that. Yes, there are quite a few questions. Please continue to send them to them. If we do not have time to get to all of them, I will personally get your email and get you that answer for any questions that we may not have time for. Our final poll is up. As we've heard a lot of acronyms today, we have a particular question we'd like to ask you regarding it. Whether you call it VRAM, whether you call it joint bond, whether you call it RPE, whether you call it, do you guys actually use it? Here in MoDOT, we use all of them. We've been doing so since about 2014 to 2015. So our final presenter, let's go back to Minnesota and let's drill down deeper. I want to say perhaps even down to, I don't know, a district or even a city level. Let's finish today's presentation with my friend Nancy Graham from MnDOT. Nancy, I can see you. And you are ready to go. Nancy?
All right, I am Nancy Graham. I am the District 2 Materials Engineer in northwestern Minnesota. And we have been doing a few projects in the last couple of years. First one was on Highway 2. It's a divided highway between the town of Wilton and Bemidji. We did about 3.5 miles of joint bond. It was paved. This project was paved in 2022. And the next season we came in and we put joint bond on the center joint and the right edge line and the rumble strips. And prior to placement, we did a mobile reflectometer readings on the pavement markings. And then we did them immediately afterwards, and then another month after that, just to make sure that it didn't have a detrimental effect to the pavement markings. So this is our data here. You can see that we did do the left edge lines also. Those are kind of our control readings, but they have recovered. Well, they didn't recover, but the other pavement markings have degraded to be very close to what our readings are on the treated pavement markings. So they're still within our acceptable limits. We're going to continue to monitor these for a couple more years just to see if the joint bond treatment actually helps the pavement markings maintain their reflectivity or not. Then we did, this last summer, we did a kind of a two-part project. We did some VRAM. You can see the purple areas here on this map. We did these on the centerline joint. This is a roadway we paved 14 feet wide. So there's only one joint in the center line. So we did VRAM, placed it directly on the milled surface prior to the tack coat, and then we paved the final lift over the top of it. The construction issues we had on this project were that you can't let traffic sit on the VRAM or drive slowly over it. It'll just peel it right up off of the milled surface. So we had to kind of train the truck drivers to drive over it and get into the lane and then back up. So something to consider. And then once the final lift was paved, we put joint bond down on these areas shown. The gaps here near Carmel and on the south end of the job, those are where the VRAM's at. We did overlap those ends a little bit so that we can see if the double treatment has a different effect. And then we did leave this section by Town with no treatment at all. So that's our control section. This one we placed on the centerline joint rumbles. And then the timing for placement was our difficulty on this one because we wanted to let the joint bonds cure as long as we could prior to placement of the pavement markings. We did let it sit for an hour or two and then they place the pavement markings. So we'll be watching that to see if the pavement markings adhere well and we don't have to replace them sooner than we had planned. This is just the placement and I have a little short video. This is what it looked like. They do go fairly quickly where they place the joint bond. And the picture on the left is after it is cured and we're getting ready to put pavement markings down. And that is all I have.
Perfect. Thank you, Nancy. We'll now, right on time, bring up all my presenters and let's enter into some questions and answers. So if I could have all my presenters pop back up. Everybody who's still with us, if anything pops in your brain of follow-up questions, I can see it, you can't. All your questions as they fly in, keep sending them. And then maybe I can kind of intersperse some of those questions as we come back and forth. So the Q&A part, I'm going to go ahead and start from top down and ask questions. And I think the first one we had, I guess is quite a simple question, I guess. I'm going to ask DOTs for the shoulders, as ours are two different pavement structures. Travis, are yours, when you pave, do you actually have a single hole or do you have your shoulders, lanes, and where do you cut your rumbles accordingly? Travis?
We have them in this center line almost everywhere. And then a lot of our roads are so narrow that we don't have enough shoulder to put rumble strips in. So that's, we haven't put them in there.
Awesome. Nancy, do you have anything for me? You guys also kind of narrow up there north.
Yeah, we have some wider shoulders, but we usually pave ours all the same mix. So we'll place them outside the joint on the shoulder if we can. If we pull it all as one pull, we just place it in that skinny shoulder outside the pavement marking.
Yeah.
And
again,
if it's a different mix, then they place it in the different mix. So.
Yeah, one of the things I didn't introduce myself properly. I'm actually in St. Louis's Metro District as their pavement engineer. What we learned, team, is we learned that when we initially back in 2014 tried to preserve our mumbles in our shoulders, but our shoulder mixes were not as high quality. So we've learned our new paving actually comes 18 inches into the shoulder, and that's actually where we've learned to put our shoulders. So good question. I didn't know the answer, but now I do. Staying with Utah real quickly. Utah, you say that you're, sorry, let me read this. You're chip sealing twice before regrinding your rumbles. What are your standard depth of your initial rumbles, and can you explain why you do that? Travis? And if you don't know, that's okay too.
I was just going to say, I'm going to be honest and say I don't know our depth. I did have our standard drawings.
That's fine.
See if I can,
don't sweat it.
I don't have that off the top of my brain, but
Brian, why don't I throw you and bail Travis out? Brian, you said 5/8 inch rumbles are deeper. When you did your standard noise testing, what was the standard depth of those rumbles as 5/8 is a deeper rumble? Brian? Are your standard rumbles less? In
Texas and in the other states that we've studied, kind of the standard for the rectangular design is a 1/2 inch, and but I've seen them go as high as 3/4, which is too high, too deep, and as low as like a 1/4 inch or even an 1/8 of an inch.
Have you seen?
Not very effective that low. So.
Thank you. I gotta wait a couple of seconds. I'm sorry. Building on that, have you seen any difference when dealing with a thin overlay versus a standard 3 3/4 inch mill fill, or was there no data behind it, Brian? Or did you know? Because the question also asks, when you're doing it through 5/8, did you have any problem with it, with peeling up of the bottom of the rumble?
So the ones that we looked at, we weren't there at the time of construction. These were, we came back, several years after construction. We did see a couple thin overlays that were failing, like a Nova chip type of mix, or some thin open graded mixes and chip seals. But like a standard thin overlay that's maybe an inch or more, we didn't see failures of those.
Okay. Dan, a vendor writes, do you have any data or experience using mastics as a repair material for the deteriorating rumbles or RPMs? And start with Dan, but if anybody else has any comments on that. Anybody have any experience using mastics?
It's going to be quick for me, Phil. The answer, unfortunately, is no, I don't. I saw that question come through, but again, yeah, curious if others do.
Anybody else use mastics?
They have used it here in Utah, and some of, you know, if the road's starting to fall apart, they'll fill it up pretty well to the point that those rumble strips are almost non-existent when they're done in some places. But yeah, I think they've used it more just to keep it from causing further problems.
Okay.
Since
you're talking, I'll ask you another.
The rumble
Go
strips are right on the construction joint is a lot of where that's the case.
Yeah. Utah and Minnesota, have you ever considered microsurfacing a 2-foot wide joint across that center line mumble and not regrinding it in general?
I guess I'm not clear what the question is there.
So 2-foot with 24-inch wide microsurfacing has been applied to centerline rumbles. And the rumbles, the question was, has anybody else done that? And accordingly, would that be something on the table? And your answer is we haven't done it yet.
Yeah, when we've applied microsurface over our rumble strips, they've pretty well filled in. Just so if we want rumble strips, we'll regrind them after a microsurface project.
And that would be what we do also, is to regrind the rumble strips after the microsurface. The problem is sometimes we grind through to the surface underneath. So
I think that's the real question that was not.
And that's where we'll come back and seal that after we've ground them with an asphalt polymer treatment.
10-4. Kansas asks, I got a little feedback team. Kansas asks, does any of the fog seal type applications on centerline rumbles cause any issues with bleed through into the striping or debonding of the striping? I don't know who to ask.
We usually, if we are going to fog seal, we call it a fog seal, or the spraying asphalt emulsion on the rumble strips. We have a duration 7 to 14 days before we'll put pavement markings down to try and get it to cure, so that it eliminates that issue as much as possible. So,
Bill, you shook your head.
Yeah. What application rate matters quite a bit too. How much film you left on the surface. So you can imagine a scenario where if you over apply a fog seal and you try and put a paint on there, regardless of how long it's cured, asphalt's a pretty low strength material. The first plows through there are going to peel it. So adhesion, any surface treatment adhesion is a big concern. Certainly true. Yeah. Nancy mentions like curing interval. There's application rate, surface texture, all of these things matter.
Anyone? Rob? They keep coming in, guys. I'm so excited that I keep getting more and more questions. I'll try and rapidly get through them. I guess just for the group, since I haven't had a chance to assign them, Dave asks, are the chip seals single application treatments? Travis, hit me.
Yeah, that's what we do.
Okay. And a follow-up question, what do you think you would do for a 4 or 5 year payment? I think this is kind of toward Nancy when you said you put them directly. Just in general regarding this particular answer, what would you do for a 4 to 5 year payment? Apparently, he also believes that a vast majority of this discussion was around newer pavements. Anybody play with 5 to 6 year old pavements, or just throwing out speculation? I'll throw it to the crowd. One of you has to talk.
well, we're doing preventive maintenance for the surface of the road about every 7 years. So we'll do a chip seal. We typically protect the centerline rumbles, so we don't allow the initial material to be placed. And then when we do the final fog seal over it, we'll fog seal the entire width of the road, including the shoulders and all the rumble strips. So I don't know about 4 or 5 years, but that's what our kind of older pavements that are ready for a preservation treatment get.
Thanks, Nancy. Bryan, did you want to say something? You may be muted, sir. I just can't hear you.
No.
Well, we'll work on that. No, I can't, but I can read your lips.
No. Okay.
Well,
I'll chat it. Oh, how about now? I've got some connection issues.
Yeah.
We can
Give
hear
it a
you
shot,
now,
Bryan.
Brian.
Now, okay, sorry, my connection is getting spotty. I was saying with the NCHRP study, we did see that the age of the pavement was a significant factor, and I can't pull up the number right now, but it was kind of at that sort of 6-year time frame that we saw more issues with, milling into that. So I think 4 years you're probably okay, but you got to keep an eye on that.
Yeah, Nancy brings up a good point. I have never actually pulled it off yet, but the idea of using that to kind of advance that chip seal and then come back at it, I think that's something we need to get on, especially in some of our rural routes. We're just not there yet. It's going to come with time, and these webinars help me understand, especially what other DOTs have done. Ironically, MnDOT has a question concerning the impact of chip seals on rumbles. Were mumbles, which is, I believe that's the middle one, or sinusoidal rumble strips looked at? I'm going to ask Dan. He looks like he has an answer. Dan?
I mean, for the current study that I was presenting, we did not do a chip seal application, but I would point the person answering or asking the question to the NCHRP. It's 15-68, 15-68, and the report is NCHRP report 1107. I think I misspoke during my presentation. 1107 was published this last June or July. They looked at chips, the effect of chip seals on mumble strips and rumble strips, noise generation, and specifically Appendix C, as in Charlie, is one to pay attention to for that report.
Awesome.
We did some of that work too for our NCHRP study, and the sinusoidal, the ones that we found, sinusoidal just tended to not be milled quite as deep as rectangular rumble strips are. So I think for that fact alone, they did kind of see a sharper drop off in noise performance, just if they're not milled as deep, because sometimes they're not. So.
Interesting. Cool. What's the ratio of rumble depth to asphalt thickness, and is this a factor in the deterioration rate? Wow, crickets. I like it. All right, I'll get back to that, Greg.
Just don't get. I don't know the magic ratio, but certainly your thin stuff, you got to be more careful, and if you don't have a good bond, it could delaminate.
Moving on. Dan, did you do any permeability testing?
We did. It was all lab permeability following the Florida DOT method. So that's where the core is encased in a little, sack. That information would be in any of the reports that you can find on the website. All of our cores, save for maybe a few outliers that had exhibited permeability coefficients less than about 150 units. That's 10 to the minus 5 units, which consensus would be those would be considered impermeable. So we're really be nitpicking at that point. So and we're around 10% or lower air voids, just to give you a frame of reference of where we're at. But they were measured impermeable. We did it on all of them.
Thanks, Dan. Rob, I have a question for you. Sharksheet, if I apologize if I mispronounce your name, asks, will the presentation be shared? I think that's it. I think that's a yeah.
So not only will this recording, but also everybody's slide decks will be available on the NCPP website.
Thank you. I have one more, unless they keep coming, but I'll ask it to the group because I haven't had a chance again to assign it. When doing a chip seal, John asks, over a rumble, do you require any special nozzle configuration? Travis?
We do not.
From a Michigan perspective, we don't ask for any variance in that either.
Cool. Awesome. Well, team, I got through the questions faster than I had hoped. I don't have any other particular questions at this time, so I'm going to go ahead and thank our panelists. I really appreciate you taking the time and turn it back over to my friend Rob Green. Rob?
Yes, thank you. Yeah, I want to say thank you to our fantastic panel and a bigger thank you to all the attendees of the webinar today. It's because of you that makes these panel discussions as successful as they are. I want to throw out there as a reminder, if there is a topic that you would like to see a webinar presented on and a panel of specialists to discuss it, please feel free. You can see my contact information up on the screen. Feel free to email me any suggestions. We do have a task force that's made up of individuals from all the 4 different pavement partnerships, pavement preservation partnerships. So that's how we've been able to expand our panel to get people from other DOTs. You know, this all started out kind of as a Midwest, but as our attendees grew, we decided to expand our reach and get more perspective from across the country. So one last item that I wanted to share, I wanted to make another plug for another great webinar series that is going on later today. FHWA is hosting session 2 on their pavement management roadmap. Today's webinar will be on performance modeling. So if any of you are involved in pavement management and want to learn a little bit more about performance modeling, I know one of my colleagues from Michigan DOT will be on that panel today, along with another good friend of ours from the Midwest, staff from North Dakota. So that is from 2 o'clock to 3:15 Eastern Standard Time. With that, I will let everyone go. Thank you again, everyone, for attending. Stay tuned for our next webinar. Like I said, either coming out in May or June. Thank you, everyone.